Our Sun, a brilliant star illuminating our corner of the cosmos, is not eternal. Like all stars, it follows a life cycle, a captivating narrative of birth, evolution, and eventual demise. This cycle unfolds over billions of years, a timescale difficult to grasp, yet crucial to understand the fate of our solar system. The story of the Sun is not just about a single star, it's about the destiny of planets, moons, and countless celestial objects bound to its gravitational embrace. We begin our exploration with the Sun's formation billions of years ago from a massive swirling cloud of gas and dust. This cloud, a nebula, collapsed under its gravity, pulling matter towards its center. The intense pressure and heat at the core ignited nuclear fusion, the engine that powers stars. Hydrogen atoms fused, forming helium and releasing tremendous energy, marking the birth of our Sun. This event set in motion the clock for our solar system, a clock that continues to tick even today. Understanding the Sun's life cycle allows us to peer into the future, to predict the changes that await our cosmic neighborhood. It's a journey through time and space, a glimpse into the grand cosmic ballet where stars are born, evolve, and eventually fade away, leaving behind remnants of their former glory. For roughly 4.6 billion years, our Sun has been in its main sequence, a stable period of its life where it steadily fuses hydrogen into helium in its core. This process, known as nuclear fusion, is the heart of our star, radiating light and heat that sustain life on Earth. The Sun's core is a fiery furnace with temperatures reaching 15 million degrees Celsius, a testament to the immense energy generated by nuclear reactions. This delicate balance between gravity pulling inward and the outward pressure from nuclear fusion defines the Sun's current state. It's a period of equilibrium, a cosmic balancing act that has allowed life to flourish on our planet. The Sun's energy bathes Earth in warmth, drives our weather patterns, and provides the energy for photosynthesis, the foundation of most life. However, this stability is not permanent. As the Sun continues to fuse hydrogen, it slowly depletes its core fuel reserves. This gradual change signals the beginning of a new chapter in the Sun's life, a chapter marked by dramatic transformations that will reshape the solar system as we know it. In approximately 5 billion years, the Sun will begin its transition into a red giant, a phase marked by significant changes in its size, luminosity, and temperature. Having exhausted most of the hydrogen in its core, the Sun's core will contract, heating up and igniting hydrogen fusion in its outer layers. This process will cause the Sun's outer layers to expand dramatically, engulfing Mercury and Venus in a fiery embrace. Earth's fate during this period is uncertain. Some models predict that the Sun's expansion will engulf our planet, while others suggest that Earth might be pushed outward, narrowly escaping a fiery demise. However, even if Earth survives the initial expansion, it will become an inhospitable world. The Sun's increasing luminosity will boil away our oceans, leaving behind a barren and scorched surface. This transformation into a red giant marks a turning point in the solar system's history. The once life-giving Sun will become a harbinger of destruction, transforming the inner solar system into a region of intense heat and radiation. Inner planets, a fiery farewell. As the Sun swells into a red giant, the inner planets, Mercury, Venus, and possibly Earth, face a grim fate. These rocky worlds, once teeming with potential, will be consumed by the Sun's expanding atmosphere. Mercury, the closest planet to the Sun, will be the first to succumb, its surface vaporized by the intense heat. Venus, shrouded in thick clouds of sulfuric acid, will follow suit, its atmosphere stripped away before the planet itself is engulfed. Earth's destiny remains uncertain. The expanding Sun might engulf our planet, ending its long history. Another possibility is that Earth's orbit might expand outward due to the Sun's mass loss, potentially sparing it from immediate destruction. However, even in this scenario, Earth would be a vastly different world. The oceans would evaporate, the atmosphere would be stripped away, and the surface would be scorched by the Sun's intense radiation. The inner solar system, once a region of potential habitability, will be transformed into a hostile environment, a testament to the destructive power of a star entering its twilight years. Outer planets, a cosmic reshuffle. While the inner planets face a fiery demise, the outer planets, Jupiter, Saturn, Uranus, and Neptune, will experience a different fate. These gas giants, located farther from the Sun, will witness a cosmic reshuffling as the Sun loses mass during its red giant phase. The gravitational balance of the solar system will shift, potentially altering the orbits of these distant worlds. Jupiter, the largest planet in our solar system, might migrate outward, its massive gravity influencing the orbits of other planets and asteroids. Saturn's iconic rings, composed of ice and rock, could become less stable and dissipate over time due to the Sun's increased radiation. Uranus and Neptune, the ice giants, might lose some of their outer atmospheres, but their distance from the Sun could shield them from more catastrophic effects. The outer solar system, while avoiding the immediate destruction that awaits the inner planets, will not escape unscathed. The Sun's transformation will leave its mark on these distant worlds, altering their orbits, stripping away atmospheres and reshaping the delicate balance of the solar system. Planetary nebula, a star's grand finale. As the Sun exhausts its remaining fuel, it will become increasingly unstable. The outer layers of the Sun will be ejected into space, forming a breathtaking but ephemeral shell of gas and dust, known as a planetary nebula. This expanding cloud, illuminated by the Sun's hot core, will create a spectacular cosmic display visible from distant star systems. Planetary nebulas, despite their name, have nothing to do with planets. They are the remnants of dying stars, a final burst of glory before the star fades into oblivion. The Sun's planetary nebula will be a relatively short-lived phenomenon lasting for tens of thousands of years before dispersing into the interstellar medium. This event marks the end of the Sun's reign as a red giant. The once mighty star will have shed its outer layers, leaving behind a small, dense core, ready to embark on the final stage of its stellar evolution. A cosmic future, billions of years of change. With its outer layers ejected, the Sun will enter its final stage of evolution, transforming into a white dwarf. This stellar remnant, composed mostly of carbon and oxygen, will be incredibly dense, with a mass comparable to the Sun's current mass, but packed into a volume roughly the size of Earth. The white dwarf will gradually cool over billions of years, emitting faint light as it radiates away its residual heat. The remaining planets and debris in the solar system will continue to orbit the white dwarf, but their long-term fate is uncertain. Gravitational interactions with passing stars over billions of years could disrupt the orbits of these objects, potentially ejecting some from the solar system altogether. The white dwarf's strong gravity could also pull in nearby objects, leading to collisions and the formation of a debris disk. The solar system, once a vibrant and dynamic place, will become a shadow of its former self, a faint reminder of the star that once illuminated its planets and gave rise to life on Earth. The universe, however, will continue to evolve, with new stars being born, galaxies colliding, and the grand cosmic cycle of creation and destruction continuing unabated.